Okay, this is question 2 of the geometry, grade 12 geometry workshop that we're going to do on March 19th. And here we go. Let's just do it. It says here in triangle ABC, F and G are points on the sides of AB and AC respectively. D is a point on GC such that D1, this angle here, D1 equals angle B. Now I'm going to call that angle X so we can look at it and say that those two angles are equal. Now it says if AF is tangent to the circle that passes through F, G, and D. So imagine there's a circle that goes through F, G, and D. Then this is a cyclic kind of triangle, and that means we're going to be able to use the tan chord theorem. In fact, if there was a circle going around here and this was a tangent, that angle F1 would be the angle between the tangent and the chord, and it would equal this angle at the top of the triangle D1. So we can say that F1 is equal to D1 because of the tan chord theorem. That was the reason we'd have to put after it. You can see the whole thing written out here in the memo afterwards. I'm just explaining it. You have to write that reason after it. Now we're supposed to prove that FG is parallel to BC. Well, now we can say that FG is parallel to BC because these F1 and B are both the same X because corresponding angles are equal. And we've just done it. Because of corresponding angles equal, it forces FG to be parallel to BC. It's further given that the ratio of AF to FB is 2 to 5. Now, I don't put the numbers 2 and 5 on here because if I did put the numbers 2 and 5, you might think it's 2 centimeters. So I don't know exactly what this distance is, but I know the ratio is 2 to 5. That's why I put 2y and 5y, just so I don't get confused later on. If we know that this ratio is this, and if we knew that AC was equal to 2x minus 6, well, the AC means all the way up to the top here and all the way down to the bottom. That's 2x minus 6. That's the long side. And if we knew that x plus 9 is the same as GC, well, x plus 9 is GC. I've got these little arrows so we can see it. Well, that's just from G, just about to G, all the way down to C. That's where x plus 9 is. Now we've got the whole picture here. We've got a triangle. We've got parallel lines, FG, that's parallel to the base here. It's time to use the proportionality theorem. That's just a little summary of the first question there. F1 equals D1, just what we did. And why are they parallel? Because corresponding angles and all that. But this question here now, we know that those are parallel lines, right? Or that FG is parallel. We can use the proportionality theorem. When you've got a line that's parallel to the base of a triangle, it divides the side proportionally. So if we were to make this fraction, let's say GC, which would be x plus 9, over AC, we'd get this fraction. X plus 9 goes with 2x minus 6. In the same way that 5 goes with this whole side, which is 7. Well, that's the big idea. That's what we're going to do. I'll make this bigger here. You can actually just make the fraction right here. You can say x plus 9 goes with 2x minus 6. The way this 5 goes with the long side of 2 plus 5 was 7. And beside it, you have to say proportionality theorem. That's why you can do it. And why can you use the proportionality theorem? Because FG is parallel to BC. And now it's just a matter of solving it. 7 times x plus 9 is 7x plus 63. 5 times 2x minus 6 is 10x minus 30. Well, we can add 30. We can subtract 7x. We're going to get 3x equals 93. And then divide by 3, we get the answer, x equals 31. So the main thing, proportionality theorem, and remember to state the parallel lines. There's another way to state that proportionality theorem, and I think they do it that way. They use a different wording here, and there's two alternate wordings that you can use. So it's kind of up to you. But I like proportionality theorem because that's what I'm using, and then stating the parallel lines. Okay, so there you go.